Hello guys, we are group 2 from DPU3. Today we are going to present about the counterflow heat exchangers for the subject DJU31012 Air Conditioning and Refrigeration System Principle. Before that, let me introduce me and my group members. I am Sam Ying Hao and my registration number is 01 DPU20F2013. Then Dawindaran anak lelaki S Siwanasa Selvan and his registration number is 01 DPU20F2006. And also Ahmad Idaham bin Ahmad Itairi with registration number 01 DPU20F2015.
Hello, my name is Ahmad Idham bin Ahmad Tairi. My registration number is 01DPU20F2015. Today, I want to talk about introduction counterflow heat exchanger in air conditioning and refrigeration. Counterflow heat exchanger is one in which the direction of the flow of one of the working fluid is opposite to the direction to the flow of the other fluid. How does a counterflow heat exchanger work? Counterflow just take one of stream and reverse it. This means that as whole fluid enters from the right, it cools against the already warm up cool fluid from the left. The temperature differential is nowhere near as high as the start of the parallel heat exchanger. What means counterflow arrangement? Counterflow arrangement means the cooling medium flowing the opposite direction to the liquid is being low. Next, I want to talk about advantage and disadvantage counterflow heat exchanger. Counterflow heat exchanger have three advantages. Number one, higher thermal efficiency used in gas-to-oil heat transfer. Number two, as require less heat surface for the same condition and are more compact. And the last is low cost. Next, disadvantage of counterflow heat exchanger have 4 points. Number one, relative smaller operating pressure when compared to shell and tube heating. Number two, typically medium to high pressure drop. Number three, relatively small tolerance to falling and chemical aggressive fluids. Number four, limitation in terms of space such application. The counterflow heat exchanger different. In a counterflow cooling, the incoming cooling medium absorbs heat as the hot fluid travels in the opposite direction. The cooling medium heats up as it travels through the heat exchanger, but as colder water enters, the heat exchanger is observed. More heat reduces the temperature much lower. Then could be a shift with parallel flow. As the illustration beside show, the mid-temperature difference between the cooling medium and the fluid being cooled is much more uniform along the latch of the heat exchanger significantly reduces thermal stress the unit. Now, I want to show formula of LMTD counterflow heat exchanger picture.
Hello everyone, my name is Darwindan Analaki S. Sivanathan and my matrix number is 01 DPU20F2006, and I'm going to talk about what are the differences between the parallel and the counterflow heat exchangers. Parallel and counterflow heat exchangers are different in the flow direction and the heat transfer diagrams. In parallel exchanges, both of the inlet are placed on the same side and we have all the outlet on the other side. The maximum temperature difference is happening in the inlet and it decreases to reach the minimum at outlet. It is totally inverse type compared to the counterflow inlet and outlet position. And temperature diagram for the parallel and counterflow heat is presented in the B-side figure. As we discussed before, the base of the heat exchangers is simple and it is the transfer of the heat from the hot fluid to cooler ones and exchanges energy between them. The surface of the plates, pipes or whatever separates the fluid in heat exchangers has a great impact on the heat transfer. And by increasing it, we can reach a high level of heat transfer for heavy duty applications.
Here, there is a question related to our topic, which is counterflow heat exchanger. A counterflow double pipe heat exchanger is to heat water from 20 degrees Celsius to 80 degrees Celsius at a rate of 1.2 kg per second. The heating is to be accomplished by geothermal water available at 160 degrees Celsius at a mass flow rate of 2 kg per second. The inner tube is thin wall and has a diameter of 1.5 cm. If the overall heat transfer coefficient of the heat exchanger is 640 watt per meter square Kelvin, then determine the length of the heat exchanger required to achieve the desired heating. And also, as you guys can see here in the lower right corner, there is a diagram or figure for this question. In a simpler word, water is heated in a counterflow double pipe heat exchanger by geothermal water. The required length of the heat exchanger is to be determined based on the information and diagram that have been provided. Before we start solving this question, we need to make some assumptions. The first one is steady operating condition exists. Next, the heat exchanger is well insulated so that heat loss to the surrounding is negligible. Then, changes in the kinetic and potential energy of fluid streams are negligible. Besides, there is no falling. Lastly, the fluid properties are constant. Apart from assumptions, we can take the specific heat of water and geothermal fluid to be 4.18 and 4.31 kJ per kg Kelvin respectively. So for now, the first step for solving this problem is to find the rate of heat transfer in the heat exchanger, which can be determined from the formula of Q dot equal to mass flow rate of water times specific heat of water times difference in T out and T in. So the rate of heat transfer we get is 301 kilowatt. After that, noting that all of this heat is supplied by the geothermal water, the outlet temperature of the geothermal water is determined to be 125 degrees Celsius from the formula of T out equal to T in minus with Q divided by mass flow rate of geothermal water times specific heat of geothermal water. Following that, knowing the inlet and outlet temperature of both fluids, the logarithmic mean temperature difference formula or LMTD for this counterflow heat exchanger become delta T1 equal to TH in minus Tc out. So the answer we get is 80 degrees Celsius. Then delta T2 equal to Th out minus Tc in. So the answer should be 105 degrees Celsius. And after the value of delta T1 and delta T2 is found, we can calculate for LMTD. For an example, delta TLM equal to delta T1 minus delta T2 divided by ln delta T1 per delta T2. So the answer is 92 degrees Celsius. Then the surface area of the heat exchanger can be calculated from formula AS equal to Q dot divided by overall heat transfer coefficient times delta TLM, and we will get 5.11 meters square as the answer. To provide this mass heat transfer surface area, the length of the tube must be 108 meter. By getting this from the formula of L equal to surface area divided by pi d. That's all from me. Bye.
Finally, conclusion. Discussion: the inner tube of this counterflow heat exchange and thus the heat exchange itself need to be over 100 m long to achieve the desired heat transfer, which is impractical in case like this. We need to use a plate heat exchanger or a multi-pass shell and tube heat exchanger with multiple passes of tube bundles. Counterflow heat exchangers are more efficient than parallel exchangers, and it is all because of a uniform temperature difference between fluid over exchanger and fluid path. Thank you.